Good afternoon, ladies and gentlemen. It's my pleasure to welcome you to this campus pitch session. The hard-die people who are here, we are very happy that you want to know more about what different universities and different educational organizations are doing to improve the knowledge of composites, to improve the understanding of composites, not only with people who already know a little bit composites and to improve their know-how, but also to introduce to people composites, people who do not yet know about composites, engineers or the general public. So the aim of this afternoon is that we will have about 10 short presentations, each not more than 10 minutes, from all over the world, ranging from France to Korea, where these university professors and educational specialists, training specialists, will explain to you how they do that, how they educate people in composite materials. So without further losing time, because we have a very busy schedule, I would like to introduce to you first Professor Jentel Swolfs from the university, the Catholic University of Leuven in Belgium. Jentel is a young associate professor at this university. He got his PhD degree in our group in Leuven, and he is specializing in the mechanics of composites and the micromechanics of composites, but he is also coordinating the composite research group at the University of Leuven, and in that sense responsible for the composite education in Leuven. So Jentel, the floor is yours.
Thank you, Ignace. So my name is Jentel Swolfs. I represent the Composite Materials Group at KU Leuven. Our group was actually founded by Professor Verpoest, who just introduced me. We do research on polymer composites in the broader sense, and we are a materials engineering department. So that's the way we look at composites from a materials point of view. Our group consists of 5 different research lines. The first one is micro and mesostructural design of composites, led by myself and Professor Stepan Lomov. Then we have process and application development, led by Professor De Splentre and Professor Evans. Bio-based and sustainable composites, led by Professor Van Vuren. Composites and principles inspired by nature by Dr. Gorbatik. And physical chemistry of interfaces by Professor Seveno. And then we have one emeritus professor sitting over there, who is still somewhat active in our group and supports our activities. We are also closely collaborating with the Sirius Leuven Ghent Composite Application Lab, which helps us to transfer technology to industry and helps us also in further training the industry to adopt the latest technology available. We are here to talk about education and training, and obviously that's very core to our mission, being a research group in a university. We train the next generation of composites engineers through our bachelor and master program, which I will talk about a bit later. We also host a range of online workshops, most recently on composite testing, but in the past also on many other topics. We run benchmarking exercises and round robins. We are quite actively involved, for example, in benchmarks on permeability measurements, on compressibility, on helmet testing to improve the way these are tested and the way the industry can implement that. And we are currently doing a round robin on unidirectional tensile testing, hoping that that evolves into a standard so that the composite community can benefit from better, more representative testing. We also run regular training programs through the SLC lab, where we then contribute some of our knowledge, some of our educational material. And we run a range of modular courses at different universities, Italy, UK, India, China, and sometimes also at companies. So these are just 4: DSM, General Electric, Toray, and Itochu, where we have recently been running courses. And we are actively involved in CLC, the Flex and Hemp Federation of Europe, which also has a big booth here and where INJAS is also very actively. We are helping there to bring together the flax and hemp companies to help them to standardize, to improve their products and to provide scientific advice on their product development. Our master program in materials engineering is a 2-year course, 120 ECTS credits. We have that in Dutch because we are in the Flemish region of Belgium, but we have an equivalent one also in English. That has 4 different options. The most relevant one for today is the options of polymers and composites, where you'll get courses by all the people involved in our group. And there's then some elective packages so you can select what is most interesting to the students. In the last 5 years, we also got involved in an EIT KIC Master on Sustainable Materials. So this is not composite specific, but composites are of course an important material in the sustainability world. This is again a 2-year program, fully in English, but this time you spend 1 year at KU Leuven and the other year you spend at one of the partner universities, which is University of Trento, Milano Bicocca, Leoben or Grenoble. And you can pick and choose in which order you do this. We are also involved in developing professional courses for lightweight materials. Again, this is not exclusively composites, but composites are an important material in the lightweight family. And this is to help companies train their workforce from basic level all the way to very advanced courses. And this is funded by the European Commission, of course. We also do a lot of training through research, helping companies to improve their products. I'm going to highlight a couple of relevant applications. So we've helped SNECMA to develop 3D woven fan blades, where we help them to model these very complex textiles and to better predict their performance. We've been involved in European projects to develop this really big automotive panel in a one-shot RTM process. We've helped an Airbus supplier in Belgium called ASCO to redesign a hinge arm from metals into carbon fiber reinforced plastics, to do fatigue and impact performance assessments for Toyota for car body applications, to help them to better understand how their impact and fatigue can be improved. We are very active in working with Samsonite, the biggest suitcase manufacturer, helping them to develop and optimize these new materials that they've introduced into this market. Self-reinforced polypropylene, and now since the last few years also biaxially oriented polypropylene laminates. On our booth you can also see an example of one of these two. We look also at bicycle helmets, which is not a composite, but we look specifically at anisotropic foams, and that's where all our knowledge on composite mechanics comes in, to develop helmets that are better against rotational impact and not just normal impact, which is what most bicycle helmets currently are designed for. We helped Owens Corning to develop better non-crimped fabrics, looking at the stitching process and how that affects the mechanical properties. In the last 5 years, we've gotten very active in pressure vessels. We have a very strong industry in Flanders, and we've supported Toyota Motor Europe, Plastic Omnium, and Coves into better understanding their process, developing better pressure vessels overall. And we are now in a European project building a bio-based bridge in the Netherlands. And the outcome will actually be an installed bridge somewhere in the Netherlands in this location you see here. In terms of spin-offs, we have Econcore. They do develop continuously produced thermoplastic honeycombs, and Reinforce, which develops as a fully automated manufacturing of thermoplastic composites for bike frames, with steel fibers added to it to improve the structural integrity. And we have a range of patents on some of the topics I mentioned, including some sandwich fabrics, hybrid self-reinforced composites, natural fiber tapes, coating fibers with nanotubes, silic fiber composites, bio-based gluten polymers, and anisotropic foams for the helmet applications. And finally, we also actively sell and train people to work with 2 pieces of software. WiseTex models textile geometry, so they make this type of 3D models, which you can then use to predict the mechanical properties. You can do permeability simulations inside that software. And this is sold, there's about 70 licenses worldwide, not just in academia, but also more than 20 companies have active licenses for this software. And in the last 6 years, we started to commercialize VoxTex, which is to quantify and to analyze computed tomography images. So when you have this type of image in 3D, you want to know where are the fibers, where is the matrix, where are the voids, and you can analyze that by looking at the anisotropy of the image and then you can segment that, make a voxel-based model, and then you can run that in a finite element, either for permeability, for mechanical properties, and so on. If you're interested to buy one of these licenses, get in touch with me. And that's it. If you want to get in touch, if you want to learn more, come and talk to me or come to our booth or get in touch via email. Thank you for your attention.
Thank you very much, Jentel, for keeping perfectly in time. We have 50 seconds for a question. So if somebody has an urgent question, not necessarily related to... Okay, then thank you very much, Jentel, and
thank you.
All the best. The second presentation will be by Marina Thibert. She is the educational coordinator of Polyvia. Marina will introduce to you what Polyvia is, but she has a lot of experience as a technical workshop manager, so she has really been working hands-on in composite materials for 20 years, and now she is working in training engineers in composite materials. So, Marina Thibert, please, the floor is yours.
Good morning, good afternoon. Thank you to be here this afternoon. Thank you for to introduce me and Polyvia Formation. Polyvia Formation is born 2 years ago. It's a merger of 4 institute trainings, and we are throughout France. We have 4 training from operator to engineer educational training. I'm going to give you a background on Polyvia Formation. It's a vocational training organization of the French Plastic and Composite Federation. And each year we train 650 apprentices and more for 1,000 professional trainees. We have the 2 types of training in Polyvia Formation. Our role is to sustain polymers manufacturers in their performance and skill development. And we are present throughout France, and we have near 25 advanced technical platform. So we have lots of partnerships all over France. We work with all areas sector, like aeronautic, automotive, energy, sports and leisure, marine industry, and construction. We have a Calliope certification. It's a French certification for the institute, training institute. And this certification attests the quality of our services. We have pedagogical methods and equipment. new pedagogical methods and equipment, and we have an innovation, a pedagogical innovation team. I'm going to show you a video about our innovation train and why to join us to train your team. Thank you. I'm going to talk about our training offer. I told you we have educational training and vocational trainings. So in Polivia Formation, we have 10 educational training with European equivalent European degrees, level 3 to 7. Operator to engineer. All our educational training are in work-study program or apprenticeships. You must know our educational training are online or in classroom or the both. It depends of the training, educational training. We have two specialized educational training in materials composite, a training for operator, and they learn the good practices and to choose the good raw materials with the good to make good products. The second one is a project manager in materials, in composite materials, and they learn design rules and eco-design, mechanical dimensioning, and different characteristics materials and how to manufacture products. We have vocational training, so we have a courses catalog. Generally, we have basic knowledge about the different materials and different processes. And but when you want to be experienced, we can propose you customized training. Our role is to know your needs. We make an analysis about your needs, and we can propose you, suggest you a training courses. You have seen in the video, we have e-learning. We have 200 activities in learning online about plastic materials and some in composite. But if you want to be experienced in e-learning, we have a partnership. Our partnership is Composite Academy here, and you will see the presentation later of Composite Academy. And we have different topics we can have in e-learning. You can have an example of training topics. So basic knowledge, processing materials and optimization. Processing materials and optimization is to have, sorry, I'm going to tell you, to have a specific vocabulary or to develop new products or to reduce scrap, it's possible, or to sustain you in technology transfer. It's possible for us, and we can create training in thermoset and thermoplastic materials in chemistry and the different countries we can have in the manufacturing. Sustainable materials.
Time is over.
Okay, thank you.
Thank you very much. I'm sorry.
Thank you.
Thank you. So please contact Mrs. Thibert if you have more questions. She will be around. Thank you very much.
Thank you.
So the next presentation is by Véronique Michaud. Véronique Michaud is professor at the École Polytechnique de Lausanne. She is currently head of the Laboratory for Processing of Advanced Composites and Associate Dean of Engineering for Education. So she is the right person to talk about education in composite materials. Please, Véronique, the floor is yours.
Okay, hello. I guess my presentation will come in 1 minute. Maybe, do I need to push? Yes, it's here. So I'm glad to be here and present what we do in composites at EPFL. Thank you, Ignace, for the nice introduction. So EPFL, you have a picture of the campus here. It's a very large school. We have about 10,000 students, so around 6,000 to 7,000 bachelor students. And it's been increasing a lot. We are one of the few schools that increased about almost 50% in 10 years, in the last 10 years. We have master students and we have PhD students. And we do teach in all aspects of technical education, from architecture to basic sciences like mathematics and chemistry and physics. And we include also life science and computer science. And we, of course, have engineering. And the composites, of course, activities are a bit more part of the engineering. I also wanted to point out that we have about 30% students who are women, and we're trying to make it even larger, if possible. So training in composite materials at EPFL is not something that is very visible, because we don't have a specific program in composite materials. It's too narrow a field for such a large university. So there are 3 ways to enter and go into composites. Is to do a bachelor and a master degree in material science and engineering, which is where I belong. So I, of course, put it first because that's my field, but also in mechanical engineering or also in civil engineering. And these are the 3 branches where, of course, composites are important. And there are specific courses given at the bachelor and at the master level, where you can learn fundamentals in composite processing, you can learn about properties, you can learn about design and eco-design. And I cite here some of the courses that we teach. Some of them I'm involved in, like the polymer composite and composite technology. Some of them my colleague Tassos Vassilopoulos from civil engineering is teaching, so in design and advanced composite in engineering structures. But what is very important for us also is not only to have a course where you learn about all the basics of composite, but it's also to participate in making composite, because as you all know, composite is just not a very academic field. It's a field where you need to know chemistry, maybe mechanics, maybe business as well, or environmental aspects, or regulatory aspects, or joining aspects, and so on. And so we have lab courses. So a lot of our teaching is done with some lab courses where you learn how to make a plate or something and do a mechanical test, but then also project-based learning. And we have the possibility for our students to be in semester or master projects in the labs related to composites. So a lot of students come to our lab to work with the PhD student and learn about composite, but also to participate in interdisciplinary projects. And I will explain to you a bit what we do. So if you come to a lab, right now at EPFL, we have 2 main composite laboratories. So we're rather small if we want to look at it this way. One, which I present on the left, is the CC lab. It's my colleagues, Thomas Keller and Anastasios Vassilopoulos. And they are working with the eye of civil engineering. So it's a composite construction lab, and they're looking at infrastructure, wind energy, hydrogen, transport, and so on, really looking at more durability, thermomechanical loading, so long-term performance of composite. They work a lot on adhesively bonded joints and sandwich panels, and they do a lot of activities related between basically the structure, but also the architecture side, because they're in civil engineering, and also the material science. So we do collaborate a lot with them. And then the LPAC, which is the Laboratory for Processing of Advanced Composites, which I lead, where we're more seeing composites from the material science aspects, working on fundamentals, understanding how processes work, what are capillary effects, this and that, but also with all kinds of applications in all fields, looking at fundamentals, looking at new resins, new systems, understanding the process, working on surface and interfaces as well, so also for adhesion and bonding, but also for bio-inspired surfaces, and integrating functions. That's the next step of composite. Of course, we have smart piezoelectric composites and so on. So, and then to explain a bit to you what projects are, I have a video which mentions some of these interdisciplinary projects that the students are doing. And you see a lot of these contain composite materials. This was, for example, the EPFL loop at that time. This is the old hydro contest. This was the Hyperloop again. This is the rocket team testing some new engines, but they also have rockets made of composite. So rocket team, you see they learn how to do composite, and they did actually very well. They managed to get some good prices. Explore is, they're making rovers for Mars, and if you see the arm of their rover at first was aluminum, and they had a lot of problems because the precision was not good. So then they made a composite arm. Suddenly it was much better. Hyperloop was an old one, which they did, and they got some prizes also. Well, this one is not linked to composites because it's more for genetic engineering, but they still make nice boxes and use 3D printing. SP80 is a project that I like very much because I'm the kind of the irresponsible professor of this project, where they are trying to build a huge boat to do the speed record in sailing. Growbot Hub is a project where they grow vegetables, so there it's more linked to robotics and environment. And then the racing team, a lot of these students were actually walking around trying to find sponsors. They are building this year, for the first time, their car fully in composite. And then we have some projects also where they look at space mission and testing life on Mars in the mountains of Switzerland. So, okay, so yeah, that's the last one, synthetic biology. So that's not really composite, but who knows, maybe one day. And then Swiss Solar Boat, it's also a project that I've collaborated a lot with. They made a boat That was at the Monaco Energy Boat Challenge last year, and they managed to get the second place behind TU Delft, which is already always winning. But we hope one day we will beat them. Okay, so that's it for my presentation. Oh, and I did very well because we still have 2 minutes if there is a question. So thank you.
Thank you very much, Veronique. Yes, 1 minute if there is an urgent question to Veronique about composites. If not, then thank you very much, Veronique.
Okay, thank you.
Thank you. The next speaker is Oressia Cauchois. She is training manager at e-learning Composites Academy. Oressia has an interesting career as she was 25 years in management positions in the Louvre Hotel Group, but then I think she decided that she had enough about managing hotels, so she came to the composites field, and now she is the training director of this e-learning Composites Academy. And what this Composites Academy is doing, she will explain us now. So, Oressia.
Thank you. Hello, everybody. So thank you for your interest in this presentation. E-Learning Composite Academy is the first platform dedicated to the transformation of composite materials. We have created innovative training courses, and they are fun to learn and accessible to all in French and in English. The target companies in the field, but also for the school, for future employees in the sectors. The courses are divided. Ça marche pas. Voilà. The courses are divided into 3 levels: initiation, intermediate, and advanced. Depending on the course and level, we provide tutoring, which can be individual or collective. We have the French Calliope certification, a guarantee of rigor and seriousness in our training activities. E-Learning Composite Academy is an incredible resource that perfectly addresses today recruitment and teams training issues, saving you all the complicated logistics of setting up. The training is focused on the processing of thermoset and thermoplastic composite materials. Our training courses enable you to master and understand the important parameters, as well as to recognize, analyze, and resolve issues. Our courses are designed for operators, technicians, project manager, design, and methods office. The strength of the concept devised by E-Learning Composite Academy lies above all the interaction of the tools provider for learners. Our cognitive pathways provide a better understanding of complex physical phenomena in a simple way. I will now introduce you the different resources that learners benefit from and that they make the learning experience unique. The platform is easy to use. Only a Wi-Fi connection is needed, accessible anytime, anywhere on tablet, smartphone, or computer. The solution allows a great freedom in the control of time and the management of events which very often interfere in a professional daily life. Videos, animations, voiceovers, quizzes, everything has been thought out and designed to give rhythm to the learning process and stimulate the learner. A rigorous and benevolent tutoring is put in place from the start of the course to avoid any dropout and to stay in touch with the student. Software and simulator. As you can see, E-Learning Composite Academy has created its own tools, and you can see them on the screen. Our software and simulators in which you can integrate your own data, materials, and now already available the software that complements the RTM and Infusion courses. The stamping simulator, digital twin, that you can see on the screen, will allow the learner to project himself into the production of parts to be stamped and to master, analyze, and correct all the parameters. The latest edition in the welding simulator, it's an educational innovation which completes and consolidates the knowledge. The simulator enables the most suitable technologies to be defined objectively according to the geometric constraints of the parts and materials to be assembled. In this training course, e-learning Composite Academy illustrates each welding technology through animation, thus promoting a better understanding of the processes covered. The potential of this new module is mainly due to the sharing of knowledge, thus creating a unique and original resource and access to a common vocabulary. So normally there is some sound, but you can see the box number 1 dedicated to RTM and Infusion courses. Is the mini laboratory that you can use to make this exercise in Infusion in RTM. And you will see after the box number 3 dedicated to the thermoplastic.
Box 3 contains a small hot press and a sample library with an exercise pack. This box is dedicated to the thermoplastic composite course.
As you can see, this unique training concept combining courses, use of software simulators, monitoring by a tutor according to the course and level, and practical exercise at a distance, is perfectly suited to initial and continuous training. The Composite Academy e-learning courses enable you to increase the knowledge and skills of your team and also to get the vocabulary on terms specific to composite. Many companies and schools already trust us. The subjects covered in our course are pioneering that meets the needs of the market and the questions of tomorrow. To conclude this presentation, we would like to illustrate with few figures the satisfaction feedback from hundreds of our learners, which will allow you to judge for yourself the effectiveness of our concept and the relevance of the tools developed. You can see the email address that appears, and for all your requests, questions, information, we are at your disposal. You can download the training catalog using the QR code on the screen, and thank you very much for your attention.
Thank you very, very much, Mauricia, for this excellent presentation and the inclusion of e-learning into education of composites. Thank you very much. The next presenter comes from far away, the other side of the globe, more or less. Professor Sung Ha. Professor Sung Ha is professor in the Department of Mechanical Engineering at Hanyang University in Korea. I know Sung Ha since, I think, about 30 years when he was a PhD student at Stanford University. And since then, he has become a leading figure in the composite scene in Korea. And he will explain to us what Hanyang University is doing in composites education. Professor Sung Ha.
Well, thank you so much, Ignas. I'm Sung Ha from Hanyang University, Korea. Today, I'd like to introduce our lab what we do, mainly on collaboration with the industry. Okay, Hanyang Structures and Composite Center. We do have several equipment. One group is the manufacturing facilities. As you can see here, we have first of all, kind of big space. 700 square meter with a 5-meter ceiling height. This is strongly supported by the Hanyang University. And we have a press machine, we have a CNC machine, we have a compression molding, and a big winding machine, so that we are specialized in winding and pressure tank, and many 3D printers. And another equipment we have is for the characterization of material, especially fatigue. We have a 9 fatigue machine to characterize the, we can characterize the composites. And dropped tester, these are about the test machine. And we also have our own design simulation tool covering from virtual coupon, meaning that micromechanics, where we can analyze the interaction between fiber and resin system. And also we do virtual manufacturing simulations, such as draping and RTM and consolidation. And also we call virtual performance, means that we characterize the impact behavior and fatigue behavior of the main structures. And final group is we call a virtual application, like the simulation of wind turbine blade and construction rebar and pressure vessel and sheet molding compound. So with the whole package of software, we are able to design and choosing right material. And then, as I shown before, we can manufacture and we can do a test. Okay, well, when we develop the composite structures and composite development, is very important to perform the cost analysis together with the technology. And so we are doing this cost analysis of a composite for many different types of manufacturing. Okay, this is the overview of the Hanyang collaboration with the composite industry. Again, we have 3 groups. One is the materials and design and manufacturing, starting from the resin suppliers such as the Arkema and Swanco, and also carbon fiber. So they are supporting us and they want us to characterize their material for different applications. And also we design for different structures such as the wind turbine blade. And we also work with the Embraer for design of aerospace structures. And we also work with the Technip FMC for the flexible riser for the offshore, and also work with the Petrobras. And TSME and Agista is the Indian company who like to produce the hydrogen tank. We also work with us. And 3P.com is a startup company in our lab, and we are mainly develop the hydrogen tank. And then we closely working with the Hyundai, who are leading hydrogen tank and the hydrogen automotive. Okay, well, I'd like to introduce a little bit different subject, which is an ongoing project. One is the 3D printing of the real structure, big structure. It's a 10-meter long mock-up ship. And DSM is the Korean ship builder. They want us to characterize all the material property, because this is a 3D printing and fully anisotropic. We need to know how to analyze the structures. This is a very much different procedures of analyze. We need to consider the different material property along the printing direction and transverse direction. So we developed the technology so that they can better design of this mock-up ship. And on the right, we have a development of a high flex 2. There's mainly for the Technip FMC. They developed the pipe for the offshore applications. We've been developing this design tool for last 5 years, and then we are very proud that they are accepting our design tool to design their structures. And another one is the developing hydrogen tank using steel wire, hybrid and carbon and steel wire. The main purpose is to reduce the cost. As you can see this bar chart, you can see how the cost will down with considering the steel wires. And then again, we not only design but we manufacture. And as you can see on the bottom, we do a burst test again, and it passed the burst requirement. On the right, we also develop a recyclable wet winding hydrogen storage tank. We work with Swanco, we work with Aditya Bora in Indian group, and also we've been working with Akema, which is excellent, provide excellent resin. It's called ilium. That's a liquid but thermoplastic. Okay, we also have a strong research on development of the automatic tape layering machines, mainly for the layering thermoplastic tape. That structures can be just a generic thermoplastic structures, and also for the high pressure tank of the thermoplastic. That's the ongoing project. Our main technology to develop is first we develop the these machines we call automatic layering head machine, and then we are using the 3 different types of heat source: laser and HUM3 and ultrasonic. That is the very interesting, very industry-oriented project we are doing. And then we collaborate with the Cologne, and we collaborate with Helios. They provide us the HUM3, and we develop the all pressure vessel. That is the ongoing project. Okay, this is the last slide. Again, I'm from Korea, where we are trying to have a big network and helping many companies in Asia, covering India and also China and Taiwan and Malaysia, so that they can work together and within one supply chain. So supply chain such as resin and fiber and liners and tape tank production, I hope they get all benefit within this network. So again, our center, the main goal is to help grow global hydrogen tank market through networking and collaboration. We also, through a supply chain network, and we provide the platform for the project collaborations. And we also provide the training and exchange of information, and very importantly, how to get the standard and certification. We also help them to get the certification of the hydrogen tank, and also help developing marketing. And we like to also link to a European society and market and technology. That's what our center is currently focusing on. Thank you so much.
Thank you very much, Professor Ha. Thank you. So the next speaker are in fact 3, and I will be very brief in introducing them, and I hope they will be able to stick to the timing. The trio consists of Ka Ho Yim. They are all of Institut Mines Télécom here in France, and of Mines Paris in France, and Mines Albi in France. So Ka Ho Yim is the manager in charge of the Institut Mines Télécom scientific animation. Ka Ho Yim, please. Then we have Séverine Boyer. She is CNRS researcher at Mines Paris here in France as well, please. And then third is Quentin Gauvignon. He is maître assistant at IMT Mines in Albi. And I hope you 3 can manage in sticking within the 9 minutes and 16 seconds which you still have. Please.
Institut Mines Telecom is the public higher education and research institution of the French Ministry of Economy, Industry and Digital Technology. So our courses interface technology, economy and society. We involved in the three main current challenges: digital transition, energy and environmental transition, and the manufacturing of the future. So now we present some courses at Institut Mines Telecom. Of course, please visit our website for more information. So the first degree, for example, at EMT North Europe in the north of France, we have a 2 years Master of Sciences, a 2 semester in engineering, materials and manufacturing process and eco-design and computer-aided design, 1 semester in the business and communication at the EMT Business School in the south of Paris. And the last semester is for training or to prepare master thesis. Another example is in INSIC with a master program in a mechanical design with some basic scientific courses like mechanicals of materials and processes, some computer sciences courses, for example, numerical simulation. With this degree, a student can become a product engineer or numerical engineer. So now I let my colleague to present other courses in Albi.
Okay. So hi. So in Albi we have different courses focused on composite materials. So for main engineering degree, so we have it's a general engineering degree, but we have a specialization in the second and third year where they can choose different topics, and one of them is materials. And within the materials option, we have different, again, majors and minors, one of which is around composite materials. So they have around 180 hours specifically focused on composite materials, looking from the material itself, the fiber and the different types of resin, looking at also the manufacturing processes and the structural engineering, structural calculation of composites. And they finish with a little project where they will have to manufacture a small part in composite and test it. And then the second one is a new formation. It's Advanced Master Pre-NEC. So it's all around process and materials for the circular economy. And on this, well, we will talk about composites and the recycling of composite, the eco-design with composites, because composite is one of the materials that we all use. And the recycling, we can see it here that it's very pregnant now. And as we grow the use of composite, we'll need to recycle it more. And the third one, it's also an advanced master, taught in English. And so it's en passe master, so it's advanced manufacturing process for aeronautical and space structure. And it's joint venture between IMT Mines Albi and ISAE Super-Héros in Toulouse. So it's about 12 months and taught in English. And in this we have about 130 hours of courses, also all around composite manufacturing and also the industrial organization, management of production. And they also finish with a project where they will need to design a part, manufacture it, and then plan also the industrialization of the part. And then I finished with a 6 months internship and professional thesis. And well, now we'll let a talk to Mine Paris.
And now from Mine Paris Tech, so as you can see, we have three kinds of class.
Maybe a little bit closer to the mic.
Okay, so we have three kinds of class, as you can see. So two are located in Sophia Antipolis. It is near Nice, or Cannes, if you want to better see where is it. So one, the name is MapMod. So it is about digital materials and advanced processes modeling. And the second one is about HPC, so it means high performance computing and all what we can find about intelligence artificial. So these two classes, as you can see, it is in English. And the first one, the MapMod one, is based on classes about materials. As you can see, it is about mechanics. It is about numerical analysis. It is about materials physics and how it's possible to understand how we can make new materials and how we can modeling the behavior and how we can make simulation. So it is how we can see about this class, and the students can have some specializations. It is about numerics or mechanics or about physics on polymers or about metallic systems. The second class that we have in Sophia Antipolis, it is only about numerical and simulation, as you can see. So it is about management, how we have to manage projects, for example. It is about method, about science, of course, computing, high performance and programming to make algorithms, simulations, modeling. And you can see that this class, that is only about numerical, is to go to the digital society and to make new challenge how we can propose new understanding based on the numerical tools. And the last class that we propose, it is this one in Évry, so it is near Paris. And the next year it will be near Versailles. They will change the place. And this DMS classes is about design of materials and, as you can see, the morphology, the structure of the systems. And this class is in French, but of course it can be in English because our teacher can speak English. And you can see here it is more based on metallurgy. So it is about mechanics, physical, numerical analysis, experiments, of course, but about metallics. And you can see that we have some focus about the class, about plasticity, physical analysis, finite element, and of course, the student can select some specialty, so it is numerics, experimental, and so on. So it is all the three kinds of class that we propose at Mine Paris PSL that is located in Évry and in Sophia Antipolis. So thanks so much.
Thank you very much for staying perfectly in time. Thank you very much, all three of you. Thank you. Then we move to Tommaso Mullejans or Mullejans. I'm not certainly sure how to pronounce the name. Tommaso is business unit manager at the Native Lab, which is the training unit of managing composites, the company managing composites. And he will all explain you what this training unit of managing composites is doing for you. So, Tommaso, the floor is yours.
Great. So I hope everyone can hear me fine. Thanks for coming, even if the show is coming to an end. Thanks for introducing me. And yes, so I'm the business unit manager at managing composites. Just briefly about managing composites. We are an engineering company that works on turnkey projects, so leading all the way from very conceptual phases to manufacturing, going through design. But I'm not here to talk about managing composites, but the unit I lead, which is the Native Lab, and which is focused on training. So the engineers who started managing composites pretty early in their days, even before they started the company, they had the feeling they wanted to have more training, more applicable training and industry-related training to composites. And when they then finally started their company, they thought, well, it's a good moment also to start something in training, to give back to industry what they had, the knowledge they had gathered throughout the years. And that's where the Native Lab started. So we're basically an online platform that is focused on training on composites. We have all different sorts of programs. I'll make a deep dive in a minute, but I think one key aspect of all of them is that through our programs and courses that happen online, but also the ones we have to face-to-face, and we do at different universities, especially throughout Spain, where we're located. They try to transmit or show the possibilities that composite materials have. There's a lot of lack of talent knowing how these materials can be used, mainly for lightweight, which is probably the most common application, but also for other other ways to solve engineering challenges in different sectors. So our main focus, or their main experience they gathered, was in the automotive sector. But what we share in our courses is applicable also in the aerospace sector and through other sectors. So this is a bit what we try to transmit, have this knowledge of our trainers put into courses, so that people who want to enter, who have entered the composite sector, can basically speed up their onboarding and start and have a career in this sector. So we have mainly 5 different programs. Some of them, especially 2, are more focused on composite materials. So in there, we look at different manufacturing processes, pre-preg, RTM, SMC. More for initial or for people who try to initiate in the composites area, but also for people who have more experience. And for example, who work in design also and want to improve the designs and learn from all the things that can go wrong in manufacturing. No, we say always that in CATIA or in a CAT program, everything works, but when you get down to the workshop, this might be a bit different. So we have different trainings, again, very focused on composites, and then we have another branch of trainings that's very much also industry related, where we show the possibilities composite materials give us to achieve lightweight. So we apply these composite materials to a monocoque or to structural components, and we show how you can simulate these structures, the design, make a business case based on the technology you want to use in the manufacturing process, etc. And then we also have some trainings, maybe a bit off topic from composites, but related to CAD and having design methodology in CATIA, etc. But all in all, I would summarize it as a platform where you can find trainings that are industry related. Our trainers are currently still working in the industry. They have previously worked at OEMs in the automotive sector, especially in the high-end sector, so companies that are very composite intense. And we try to put that together in engaging short trainings. And we have all sorts of people going through them. Currently, we have more than 5,000 students spread among different groups. So one group would be people who just sign up for those trainings on our platform. We work in partnership with different universities, as I said before, mainly in Spain. So basically we teach in their master programs. And then of course we do professional training for companies. Be it, for example, in onboarding. So we train basically people who are onboarded so that they are quickly up to date, and also for more senior profiles. On a concluding note, we are based in Spain, but as I said, most of the trainings are online, even though we're also starting some bootcamp or hands-on workshop trainings, which will be taking place in Spain, but the rest of it is all taught in English and to be found on thenativelab.com. So these different programs I was briefly outlining can be, and you can enroll in those programs singularly or even in a membership program. This is a bit what we do. All in all, I think our idea is to revolutionize the industry. There's a lot of new opportunities in the composite sector, and we also want to ensure that there is people who can work in it, and the composites that are the companies that are very active in this sector. So thanks again for coming and listening, and hope you have a good trip back. Thanks so much. Thank you very much.
Thank you very much, Tommaso. Thank you. So the next presentation, we come back to France, and this will be by Christophe Binet-Ruy. Christophe is a professor in mechanical engineering at the Institute of Civil Engineering and Mechanics in the École Centrale in Nantes, which is now part of Université Nantes. Christophe is also the vice rector at Université Nantes for entrepreneurship. And in that sense, he is the perfect person to tell us how they will transfer the know-how from university to the industry. So, Christophe, the floor is yours.
Hello, everyone. Thank you, Ignace, for your kind introduction. So I'm glad to be here today just to present a little bit more what we do in Nantes, especially at Nantes University, which is a new university we have created 1 year ago, on January 2022, and that's a new university model we created to have a new model in France where we put together some new partners. So I would like just to give you a brief overview of this new university in the field of research, education, innovation, and technology transfer. So this new university, we have together now the former Université de Nantes, which became now Nantes University. We have a higher school of engineering, École Centrale de Nantes, the School of Architecture, the School of Fine Arts. And what is unique now in this construction, in the way we designed this new university, is the fact that we have now this industrial research center dedicated to manufacturing, so IRT Jules Verne. We have the university hospital, and you have also INSERM. INSERM stands for the National Institute of Health and Medical Research. And the uniqueness of this new university is at the same time, inside the same university, you have the research produced by academia as usually, but now we have inside the users of this research, especially in engineering and in medicine and health. And this is also fueled by this new big project called NEXT, which has two scientific priorities. One is about the health of the future, where we have different topics inside, but mostly focusing on innovative biotherapy, nuclear medicine, oncology, precision medicine. And we have also the industry of the future, where to focus and advanced production and ocean engineering technology. And for this big program, we work with other partners that are in Nantes. So INRAE, which is the National Research Institute for Agriculture, Food and Environment. We have also ONIRIS, which is the Higher School of Veterinary Medicine, Food, Science, Engineering and Biotechnology, a Cancer Institute, the National Institute for Scientific Research and University Gustave Eiffel. So with this big group of people, then finally we can address all those topics together. And just to give you a few figures on that, we have presently 43,000 students, including 5,000 international students and about 8,000 staff members and 42 labs. I will just give you more details about the labs. Now, if you focus on composite, what we do in Nantes, of course, we train, educate undergraduate students, but also graduate students and professionals. So, for example, we offer undergraduate programs in different areas. With the bachelor programs, we have a bachelor in naval and marine engineering. We have a bachelor in material science and engineering as well. We have about like 300 students today in this program. We have also a master program in the material engineering, mechanical engineering, computational mechanics, and processing and advanced master in composite as well. So about 70 students enroll in that, and on average you have about 25 PhD students working in composite within 7 research labs involved. I will just give you some details right after. On average, we have about 15 faculty members involved as well, and we produce about 30 journal papers per year on this topic. And the transition from research to innovation that Ignace mentioned in his kind introduction is ensured by about 60 research engineers. So we can really transform those results from research to innovation and technology transfer through these 60 people, and we produce, for example, 5 patents per year in this field. Something I would like to mention as well is we have this very nice facility which is called Jules Verne Manufacturing Academy, which is basically designed as a factory of the future where everything is digital. You can design your composite, you can produce your composite, and you can think about the logistics also inside the factory. And it's a brand new facility which is amazing. We can offer also to students and professionals. And we have also, in terms of innovation, this Innovation Entrepreneurship Center. You have a picture down here on the left where you can bring together students, professionals, faculty members. The labs I mentioned in my presentation, there are those ones. I don't want to go in details, but usually they cover many topics: natural fiber composite, bio-friendly, biocompatible composites, heat transfer phenomena, thermokinetics, mechanics for composite on process, nanoscale materials, induction process, life cycle of composites, robotics. And now once you produce this research and you want to transfer to industry to go to higher level of TRL, you have the IRT Jules Verne that from the proof of concept can upscale to scale 1 product or technologies for customers. And also we have the possibility to provide some support in engineering and valuation of research with this capacity on central innovation. So to conclude, just 2 examples of what we can produce today within this Nantes University. The first topic I would just to show you is the Industry of the Future project led by the IRT Jules Verne in Nantes. This project is called ZEBRA. It stands for Zero Waste Blade Research. This is the very first fully recycled wind turbine blade made of thermoplastic composite. And in this consortium led by RT Julven, you have like key players for raw materials. We have the full value chain from the raw materials. You have Arkema, you have like Owen Scoring, you have the company that can produce those wind blades, and you have also 2 utility companies about like the commissioning of the product and operating these wind blades. And this is a big project, and they receive also the support of one of the lab of the Nantes University about the infusion process modeling and simulation of material characterization. And the last example I would like just to show you, it's totally different area where composites can play a very significant role, and this is the health of the future. And this is a project where basically we make new composites with hybrid organomineral composite for bone regeneration using additive manufacturing, where basically this composite is made of a cement precursor, a specific hydrogel developed at the university with some partners from some spin-off, by the way, also spin-off of the university are involved on this company in biotech, plus some viscosity modifier. And then you take this composite and you can print this composite to make scaffolds. And with the scaffold, you can introduce a scaffold in the body, and then you will have, they will promote the tissue regeneration to create something very good for health. That's the end of my presentation. Thank you for attending.
Thank you very much for this very interesting introduction to Université Nantes. Thank you very much, Christophe. So, next speaker, and we are already one before last, is Friedrich Töpfer. Friedrich Töpfer is...
Roberto.
Sorry, I'm one too far. We, of course, first have, and how can I forget, Roberto Frassine. Roberto Frassine is professor at the Politecnico di Milano, and he is not only professor in the field of material science and engineering, but Roberto is also president of Asso Compositi, the Association of Composites in Italy, of EUSIA, the European Composites Industry Association, and of Uniplast. And in this dual role, he certainly can tell us what are the needs of the composites industry in composites education and how they address this need in the Politecnico di Milano. So, Roberto, the floor is yours, and sorry for forgetting about you.
Thank you, Ignaz, for the nice introduction, even if you forgot me. Ladies and gentlemen, good afternoon. I'm going to introduce very shortly my university. Politecnico di Milano is a university, is a leading technical university in Italy. We provide high-quality training to our students, and we are recognized as leaders in education. We actually graduate 30% of Italian architects, 41% of designers, and 18% of engineers of all levels, starting from the Bachelor of Science to the Master of Science, as well as PhD programs and several master's and postgraduate courses. These are some figures of our university. So we have nearly a little bit less than 50,000 students, including master and bachelor students. Quite interesting is that we count slightly less than 3,000 among PhD students and research fellows, and more than 1,000 professors. We are a school for research, of course, innovation and business. We have nearly 250 research laboratories, 35 interdepartmental laboratories, and 6 large infrastructures for testing materials and components, as you see in this picture to the right, one example. As for coming to composite materials are taught in 5 departments. Of course, we do have a chemistry and materials department, and this is one. Then there are courses on composite material also for civil engineers, mechanical engineers, and last but not least, aerospace, as well as design. So the total of 15 research laboratories, and we got more than 8 projects. Actually, then the actual number is 10 European projects in the last 3 years. So it's a very active topic, both for research and teaching. As for teaching, we don't have a specific course in composite materials, but there are several laboratories and courses in the graduation of the 5 departments that are mentioned here. A quick overview of our research topics, starting from the Department of Architecture, Built Environment and Construction Engineer. Obviously, we are testing all kind of reinforcements, starting from GFRP large diameter bars, which are mechanically characterized and modeled especially for the anchorage system, which is always a critical part for those types of bars. So anchoring, and of course, GFRP reinforced concrete beams and slabs exposed to both elevated temperatures and cycling loading is one of the topics that is studied in this laboratory. In aerospace, here are some examples of optical fibers used as sensors in this profile, both on the leading edge and on the traveling edge. And then you have on the right a testing of a structure produced by resin transfer molding for an airplane, and then some chiral composite rib and sensorized rotorcraft wings mock-ups are completing the picture. Let's go to the research in the Department of Mechanical Engineering. We have here a train axle that is made of different parts. You have the central part made of composite material, and then the 2 ends made of high-strength steel. And these are some of the steps in the development of this axle, which went through with sheet dynamic effects, detailed structural design, bonded joint optimization at the interface between the composite material and the steel, as well as some impact analysis. And to the right of this slide, you have some detailed analysis of the microstructure of different composite material produced to simulate some natural structures like bones using different kind of materials, epoxy resins, carbon fibers, glass fibers, and unidirectional glass fiber tapes to simulate the structure of natural bones. So it's biomimetic. And our design department is mainly involved in marine applications, and you see some elements for marine furniture on the left-hand side, and some students working on the foiling sustainable moth, which is called SUMOT challenge, in which different universities around the world have a challenge to design and build a foiling boats made of recycled materials and biocomposites. Quite an interesting project. And last but not least, the department where I'm teaching and doing research, the Department of Chemistry, Materials and Chemical Engineering, and we are involved in some European projects. The one on the left is about the use of recycled glass and carbon fibers as feedstock for additive manufacturing, quite a challenging task. And to the right, the Recreate project for the development of bio-based vitrimers, which have the characteristic of being repairable, reusable, and possibly recyclable epoxy systems of the future. These are our final, this is my final slide, some figures about our research results that you can read on your own. So I wish to thank you for your attention.
Thank you very much, Roberto. And by the way, I have to talk to you after the session still about Ursia. So thank you.
My pleasure.
Thank you very much. So the next speaker is then Friedrich Töpfer. And Friedrich is professor at the Technische University of Dresden at the Institute für Leichtbau und Kunststofftechnik, which is in English the Institute for Lightweight Design and Plastics Technology. He is a young professor and he has been working at several places, amongst others in INSA Lyon, at the ThyssenKrupp and so forth, at Rolls-Royce. And from that experience, he will be certainly able to tell us what they are doing in the education in composite materials. So, Friedrich, the floor is yours.
Hello together. Thank you for the introduction and the warm words, and welcome to my today's presentation of the Technical University in Dresden. I'm pleased to present you specifically our Institute of Lightweight and Polymer Technologies. All right, there we go. So basically, the Technical University of Dresden consists of 18 faculties, and we represent 5 main areas, which are engineering science, we have humanities and social science, we have mathematics and natural science, civil and environmental engineering, as well as medicine. Our university currently has 32,000 students, of which are 50% engineering related. With 7,600 employees, we are currently one of the biggest employers in Saxony, and of those 7,600 employees, we have 240 employees at our institute, the ILK. Yeah, when it comes to the Institute of Lightweight Engineering and Polymer Technology, we are the leading international institute for research, development, and student education in the field of function integrative lightweight engineering based on multi-material design. Our institute is divided into 9 expert units, which are lightweight design. We have an expert unit for thermoset processes, for thermoplastic processes, for sustainable materials and processes. We have also testing methods and material models. We have computational mechanics and methods. We have joining technology, function integration, and special materials and processes. Our institute is situated in the city of Dresden, actually quite in the center of the city. We have, here you can see 4 main buildings. The main building is the principal building for our research associates. We have our Polymer Application Center, we have the Process Development Center, and the Lightweight Innovation Center. And also, since last year, we have our Lightweight Validation Center. This was opened last year, and there we specifically want to bring the research-related topics we are dealing with at the ILK into the industry, especially for small-sized and medium-sized enterprises to keep their competitiveness within the industry and to strengthen our local, but also the European industry in general. When it comes to the branches we are dealing with at the ILK, we basically deal with everything you can, what you can imagine. We have the space industry, the automotive and rail industry. We are dealing with energy generation, storages, and manufacturing technologies. And when it comes to the aviation, We also are part of the UTC partnership from Rolls-Royce, which means we have a strong link with Rolls-Royce as our industry partner, and we have several projects which are related to Rolls-Royce topics. This allows researchers to get industry experience at an early stage of their research. But of course, for our students, this is also an opportunity for internships, and also we present those research-related topics in our courses. When it comes to the topics we are dealing with at our institute, we like to look at the whole chain of the process and of the product development, which means we are taking care of the material, which could mean material modeling, material characterization. We take also care of the composite design and lightweight design. We have specialists for simulation methods and computational mechanics, also the processing technology, as well as the quality and the life cycle analysis. The research priorities until 2025 at the IEK, we mainly want to focus on closed material and product cycles through design for circulation. We want to reduce the component and material diversity. We are focusing on climate neutral, biologized production processes, as well as model-guided and AI-based self-optimization of processes, which means we are looking on AI-based development, production, but also on recycling. And we want to have a complete virtualization and cross-lifetime recording of component properties and the material history. And all those research areas could be your topics for thesis or dissertations at the ILK. So if you're interested, feel free to contact me or one of my colleagues through whatever, email or LinkedIn. When it comes to the lightweight engineering field of study, the content is based on the Dresden model, function integration, lightweight system construction in multi-material design. So basically the study field is divided into three main fields. We have material lightweight design, we have design lightweight design, and we have manufacturing lightweight design. Within the material, we are dealing with, as already mentioned, material characterization and simulation. Within the design, lightweight design, we have structural simulation and function integration. And within the manufacturing, we are looking on and focusing on process simulation and quality assurance. Of course, we also have international partnerships with different universities in Europe, but also around the world. So for each student as well as researcher, we offer the opportunity to gain international experience by doing an exchange as a researcher or as a student. And this allows you to gain international experience and to get to know another culture and whatsoever. With that, I want to thank you for your attention, and I have finished my presentation now. There are 2 minutes left. I have also put on the down right side the contact of my group lead, Sebastian Spitzer. So if you have any questions regarding the research topics or studying at the university in Dresden, feel free to contact us, and we would be pleased to welcome you one day at the Technical University in Dresden. Thank you very much.
Thank you very much, Friedrich, for this clear and excellent explanation. Thank you. So, and then last but not least, we have our guest from Greece, Professor Vasilis Kostopoulos. Vasilis Kostopoulos is a faculty member of the University of Patras in Greece and is director of the Applied Mechanics Laboratory at the university. Vasilis has more than 25 years experience in composite materials, and based on that, he certainly will be able to explain us how University of Patras is teaching people composite materials. So, Vasilis, the floor is yours.
Good afternoon. Thank you, Ignas, for the introduction. I'm going to present, I'm not going to present University of Patras, I'm going to present our lab, who is the leading entity in the University of Patras in the field of composites. If you meet any people from Greece and you, just a moment to see how it works.
The green buttons should do it.
The green one?
The top green button.
Yes, the top green button. Okay. If you meet around the world any Greek people, Greek that works in the field of composites, and ask him from where his origin are, he will say to you that he comes from University of Patras and especially from our lab. This is a job that we are doing since beginning of 80s, and we continue in that direction. We are part of University of Patras, School of Engineering, and part of the Department of Mechanical Engineering and Aeronautics. Our lab is established back in 80s, and currently there are 5 faculty members in the lab, but in the lab there is personnel that is over 40 people. I would like to say, and I'm very proud for this, that these 40 people are paid from money from budget coming from research activities, 95% out of Greece. And this is for us very important. Let me tell you that our main field of work is structures and materials, and of course we focused in the field of composite materials. The fields that we cover is design, analysis, and optimization of composite structures, and of course computational mechanics, and NDT and NDI, plus structural health monitoring, with many applications further to this. And of course the field of materials, where we are doing composites, hybrid materials, nanomaterials, process development, characterization and testing. Let me just tell you that our lab is well known for its work, for its scientific work, but our main mission statement, and I'm going to show it you later, is both education and research. And of course, innovation in the field of trying to transfer knowledge to the industry. However, this is not the very often case in the case of Greek industry, although we support the Greek industry. Just some idea about how the students are enrolled to our department. The enrollment is, we enter every year close to 150 students. At the end of the day, we split this to mechanical engineers and to aeronautical engineers. And the mechanical engineers, you may see here, are constituted from four divisions. And based on these divisions, we belong to the division of applied mechanics, and from applied mechanics we support every year more than 30 people in the field of composite materials. These are the underlying courses at the undergraduate course, and the graduate courses are the courses that we teach in the curriculum of our department: introduction of composites, experimental mechanics, composite mechanics, manufacturing methods of composites, NDT, non-destructive testing, of course, damage tolerance, design with composites, physics and chemistry of composites. These are the courses. Okay, I'm going very fast through the mission statement. As I told you, our main goal is education and research. These are the topics, the four basic pillars of our work in the field. I told you earlier: design, analysis, and optimization, and computational mechanics, non-destructive testing and SHM, materials development, characterization and testing, and very recently We have work in the field of UAVs and nanosatellites. We are certificate and accredited in various fields. The most important that makes also the change in our approach on the field is that the lab since 2009 is accredited under EN 17025 for mechanical testing of metal, plastic and composites, quasi-static and fatigue, and both at ambient and high temperature. Of course, we are also accredited in various other fields. Since we have very externalized activities, we expose ourselves to competitions. We are awarded with various awards during the last 15 years. I'm going very fast. These are some of the recent international cooperation we have. As you may see, the majority of our partners comes from the European industry, and this is very important for us because this secures our sustainable work. These are the main sources of funding for our research projects, and these are some of the titles of our recent research projects. I'm going just to tell you that we participate in the Horizon Europe. Very recently, we awarded some of the projects, and we are a member of clean aviation activities, where we have win in or participate in 2 activities. We have some patents. We have some spin-offs that came out from our lab. These are successful stories for the Greek environment, and both of them are very healthy industrial entities. Our main power is our student, and I would like to say that the hands-on projects are the way that we have a very close cooperation with our students, and we expose them to international competition. And we have, through this international competition, we keep and work with the best of the student, having the experience of doing a lot of different projects and at very high level. Some of our students that have a very successful career abroad. I'm going to pass very fast. We are very well equipped, not by using the money of the state, but using the money from the research projects. We cover all the span of mechanical, physical characterization, and of course, manufacturing techniques. We have all this equipment. Of course, there are very strong PhD theses that take place in our department. Some of the successful stories you saw earlier are PhD students from our department that make career abroad. And the last thing that I would like to stress is that through the European projects, through the research that we perform, we try to introduce this knowledge to the educational courses, and this is very critical for us. However, I think that there are some open questions how we are going to deal with machine learning and artificial intelligence, and how we can introduce this kind of topics in our education, keeping the physics-based approach. Thank you very much.
Thank you very much, Vasilis, for this clear presentation of your lab. And by this, we are at the end of this campus session, campus pitch session. I hope you have learned a lot about the scene of composites, mainly in Europe, but extending to Korea, the scene of composites education and composites research at European and a Korean university. So I thank you very much for your attention, and I hope to meet you again next year, the latest at the JEC World 2024. Thank you very much.